ahead and do this. I'm going to take the derivative of both sides, and I get dy dx. On this side, the derivative of this is going to be a power rule. Bring the power down. Keep the inside the same. Reduce the power by 1. And then multiply by the derivative of the inside, which is going to give me a multiplication of 2. Alright? Cleaning it up, I got a half and a 2. They knock each other out, leaving just a negative 1 times 2x plus 5 to the negative 3/2 power.
Is it okay if you did? Yeah, that is like so easy.
Okay.
Is it okay if you did negative 1 over the 2x plus 5?
Could you rewrite this as 1 over 2x plus 5 to the 1/2? And then use the quotient rule? You could.
No, like the answer.
Oh, can you write this answer down as negative 1 over 2x plus 5 to the 3/2? Yeah, that's perfectly fine. And I wouldn't be surprised that on some of the multiple choice questions, that's exactly what they do. The jerks. All right, so there's 35. Is 37 similar?
Yeah.
Okay, why don't we just kick through 37 as well right now? So 37, y is equal to x times the square root of x squared plus 1. Of course, I don't like it that way. I assume that you don't like it that way. Yep, so we're going to rewrite that square root as to the 1/2 power. And now we're ready to take the derivatives. The derivative of the left-hand side is going to be dy dx. The derivative of the right-hand side is going to require the rule. Product rule. Product rule is correct. First, times the derivative of the second. Drop the power down, leave the inside the same, reduce the power by 1, derivative of the inside, plus second, times the root of the first. And there we go. Clean up. Those two cancel, giving me an x squared times x squared plus 1 to the negative 1/2 plus x squared plus 1 to the 1/2. I would really surprised that that's the notation they left the answer in the back of the book. They did? Yeah. Okay. Then I'll leave it that way too. That's 37. How about 39? Oh yeah? Like,
No.
like oh yeah Kool-Aid kind of oh yeah? Okay, we don't like that notation. So we're going to change this to 1 minus x to the 1/2 to the 1/2. So the derivative is going to be, drop the outside 1/2 down, leave the inside the same, reduce the power by 1. Now multiply by the derivative of the inside, which is going to be negative 1/2 x to the negative 1/2. Clean up. Negative 1/4, 1 minus x to the 1/2 to the negative 1/2 times x to the negative 1/2. I imagine that they take this and make this into 1 over 4 square root of x, square root of 1 minus square root of x. No? They leave it just like that?
Yeah.
Really? I got a 1/2 right here and a 1/2 right there. So I just took all those common coefficients and pulled them all to the front. Okay. So that's 39. And 41 has got the same flavor. Sort of a chocolate marshmallow flavor with a swirl. We ready? Yep. All right. 41 then. Y is equal to 3 cosecant x to the 3/2 power. So dy dx is going to be 3 times, let's bring the power down, 3/2, leave the inside the same, reduce the power by 1, and now we got to do the derivative of the inside, the derivative of cosecant, since it's a co, it's negative, and it's cosecant x cotangent x. Clean up. Not too much going on here. 9/2. And I can't combine those at all.
Wouldn't it be negative 9/2 because you have a negative?
Oh, yep, negative 9/2. And then, yep, this is going to be cosecant x to the 1/2 power, cosecant x cotangent x. I think that's it.
In the back of the book, they did the cosecant to the 3/2 because they.
Oh, they do combine these. This is cosecant to the 1/2, this is cosecant to the first. Yeah, that makes sense. So negative.
Did you have to, or?
Well, again, it's one of those things where you should feel comfortable with that kind of manipulation so that you can get to the answers in the multiple choice section to make them match. Okay, yeah, I should have saw that coming. And that's 41. I think we'll stop that one and we'll just do 59 and we'll be done for the day.